College. I am recording the workshop today, and that's just so that we can come back. You can revisit this if you'd like, if you missed anything. The workshops are typically available by the next day on our YouTube channel. Just go to YouTube and type in the Rec Innovation Lab, and you'll find hundreds of videos from previous workshops there, and including this one as of tomorrow. And the workshops or the videos that we were just watching were videos of some of the student startups coming out of the rec. And the person who's giving the or hosting the workshop, giving the workshop details, talking about building these MVPs today, is actually also a student at the Rec Innovation Lab who has a startup out of the rec, and he's won so many competitions from his startup. He's recently given some TED Talks. He's had a lot of venture capitalists approach him about funding his idea that he's creating out of the rec, and so there's no better person to talk to you about how to rapidly iterate your idea and get your product into the hands of users as soon as possible by using rapid prototyping, 3D printing. So I will pass it over to Raj to tell you a little bit more about that process and how you can also use 3D printing to rapidly get your product into something real, right? And into the hands of the users. And we do have three 3D printers that you can use at the rec, and they're available for all of our rec students to use. And Raj is going to show us how. So take it away, Raj.
Thanks so much for the intro, Tanya. Yes, I'm so excited to be sharing with you all today, and let's just get right into it. All right. So, hi everyone, I'm Raj Pabari. Thanks for the intro, Tanya. I'm a founder here at the Rec, and I'm building a hardware product myself using computer-aided design and 3D printing. And today, I'm going to be sharing with you all how to approach this, because might be a scary or daunting task, but the whole goal of rapid prototyping is that it really is a rapid process, right? And so you have to know what to do, but doing it is not, I guess, it's hard to get started, but you should be able to, after this workshop, get an understanding of like, what do you need to do? Learning these skills, they're not that hard. And so our goal today is that by the end of this, you'll have the methodology and some resources to innovate with a hardware product. So if
and
you,
Raj, I don't mean to interrupt, but I like that you said that. I just want everybody to really go into this with the idea that you don't have to be perfect, right? We don't like perfection in entrepreneurship. We like progress. And so I'm glad that you said that. I'm glad that any of you who are out there who are feeling intimidated, please don't. It's something that's really doable. And so yeah, thanks, Raj.
It certainly is. Yeah, I mean, it's totally doable. And so come into this with an open mind. I mean, this will be a lot easier than fashioning something out of wood or fashioning something out of metal. This will be the easiest prototyping you've ever seen, is my hope. So if you have an idea for a hardware product or a feature that you want to add to your company, hopefully by the end of this, you have the tools that you'll be able to do that. That's my goal. And so how I want to approach this is by giving you a way to approach hardware products. Where do you even get started, and how do you innovate with a hardware product? So the approach is, first, you need an idea. And so you get an idea for a product or a feature, and you sketch it on a piece of paper. I mean, that's the best way to get started. Second, you need to design that. So take the paper sketch and refine that. You need to get some dimensions of your product and get some other specifications to really crystallize the design in your head. And then you're going to recreate that on a computer with a computer-aided design program. And then finally, you actually create that. And so then you're taking this idea and turning it into a physical product. And for this, today, we're going to use 3D printing, but you could also use another method. You could, cut it out of cardboard. You could use foam. You could use a variety of different methods. But today, we'll use 3D printing for a part. And so by the end of the day, we're going to start with, in the spirit of rapid prototyping, I'm going to give an idea, and then we're going to go all the way to creating a physical part within the next hour. So that's the goal for today. And here we go. Let's do it. So before we get into that, I want to just take a step back with this prototyping approach and give you an analogy as to why this makes sense. It's in essay writing. So all of you have written essays, right? And so to start an essay, you start with an idea. You know, what do I want to write about? And so maybe your thesis is you want to write about why penguins don't get cold because they live in the cold. Great. So that's your topic. And now I've come up with a thesis, right? And I've given you a thesis sentence. Then maybe I'll create an outline of this. So, okay, penguins don't get cold because they live in the cold. They've never seen warm, whatever, right? There's your outline. That's your idea phase. Now your design is you're going to open something on a computer, right? Microsoft Word, or you're going to get Google Docs to type out some sentences into a text editor. You'll take this, make it into an essay, and then you're going to revise and edit it. So this is like refining that essay. That's your design phase. And then finally is creating it. So taking that, what you've written on a computer, and turning it into a physical product or a physical thing is using just a regular printer to print out that document and handing it into a professor or doing whatever you will with that essay. So this is the same approach that you all use just naturally when you're making a 2D product, right? Or you're writing an essay, or you're really making a lot of things. You could use the same idea, design, create methodology to approach it. So this is a very good way to approach prototyping, and it works very well with 3D printing. So that being said, let's get right into it. So for practical purposes, we're going to start with the create phase first because we have to get a 3D print started today. But first, let's talk about the idea, right? So what do we want to build today? And so the idea that I came up with, I was out camping, and when I was out camping, I had flies on my food. So, you know, I was eating food, it was some steak, it was good, but the flies really wanted a piece of it as well. So the idea that I had is, what if you could have a fan that spins, and with that fan, it would keep the flies away. So you put it up next to your food, it spins around, and that way there wouldn't be any flies on your food. You wouldn't have to worry about shooing them away with your hand. Instead, you could just use this fly swatting contraption in order to get the flies away. And so in order to do that, I got a little motor. So this is a little motor with a shaft, and it spins around. And then I also got a fan that fits onto the motor and spins around. So here's our product. The only problem is that I'll direct your attention to the other camera that I have in this meeting. If you put this on a table, it just falls right over. So as you can see, it's just falling over. And so there's no way for this to stand up because the motor is kind of oddly shaped. And so in order to fix that, what we're going to do is create a product that actually helps this motor stand up so that we can use it and put it next to our plate of food. And that way this fan will spin and we will be able to keep the flies away. So this is a nice, you know, simple product. It could be useful when you're out camping, keep the flies away. And this is what we're going to make for the next 45 minutes. So, all right. We're going to start with the create phase. So does this make sense, everyone, what I'm making? Because if it doesn't make sense, what I've just, like, I don't know, my pitch for this fly swatting product, then you're going to be kind of lost for the next 45 minutes. So this is what we're making. It'll become clearer and clearer how we're going to do it. But the what part of it is making something so that this motor can stand up. Right now, it doesn't stand up. And we're making it so that then it can keep the flies away from your food. Okay. So I've already designed something for this. And so what we're going to do is take this and put it on the 3D printer. So we're going to start with this create phase. And in order to do that, let me explain, how does a 3D printer work? So the 3D printer uses molten plastic. So it's got this burning hot extruder that operates at about 200 degrees Celsius. So really, really hot. And it's taking this plastic filament and melting it or burning it into layers so that it can form or fuse together apart. So here's an illustration of what that looks like. So there's a nozzle that's extruding the plastic. So the plastic's that silvery stuff and the yellow thing, and it's printing layers on top of each other. So the bottom of the stack would be like your build plate, and then the nozzle has extruded all of those lines onto the build plate. Now these lines are so close together, and because the nozzle is so hot, they actually fuse together. So the plastic, all these little things, these little lines, they're all plastic, the crisscross lines, and then because the nozzle is very hot, it fuses them together and makes a solid plastic part. So sometimes you can see these little layers if you look really closely at a 3D print. The result is that because all of these get melted together, it's squished together plastic, and it turns out you can barely even tell that there is any 3D printed layers, but this is in reality how it's created. So if you ever watch a 3D printer work, it'll start by extruding a layer and then move the bed down a little bit and extrude a little bit more, move the bed down, extrude a little bit more, and then it keeps doing that until you have your part fully complete. So I've already designed the part, and I'm going to show you how to get the 3D print started. We'll get that started, and then we'll go back to phase one and get to that point again. So let's head to the 3D printing software. What this software does is it takes the part that I've designed and breaks it up into these layers. So as you can see in this design, there's these 3 layers, and the nozzle needs to be given instructions by the printer on what to do, where does it travel, and how much plastic does it extrude. This software takes a part that I've designed on the computer and gives the nozzle those instructions. So if we open this, I'm going to import the part that I designed. And now it's inside the printer. So this grid surface is a computer representation of the printer. And the physical printer, this is a MakerBot printer, and the physical printer is, there's a little camera feed of it, is right there. So this is the physical printer. It's got a blue bed, and we can print on top of this. So this gridded surface is the blue bed. The arrow at the front is pointing like where that MakerBot symbol is on the physical printer. And so now what we have to do is get a preview of this. So you take a preview. So what we can see is that it is slicing this up right now. That's what it's doing. And now that we have a sliced image, you can see a preview of how the printer will print this thing. So if we play the animation, let's see, I'll just drag this up so you can kind of see it starts from the bottom, and then it's going to build up this piece layer by layer by layer by layer. And then within a layer, what it's going to do is, let's see, it's kind of hard to see that. So I guess, yeah, within the layer, it will, it's going to build up each of these little green components. So as you can see, it's building up, 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 all the way to having a full green part. So again, we're starting with this gray part and then turning it into a green part that's being built from the bottom, melting plastic up, 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 and it'll go all the way to this. Now you can see that there's some orange material. So the orange material, that's called supports. And so supports are when it's basically just extra plastic. The bottom line is supports are extra plastic. The reason why there's extra plastic, so if a printer is trying to print on top of a bed, it can melt plastic and put it right onto the bed. But if a printer is trying to print over empty space and it's melting plastic, that plastic doesn't have anything to go on top of. And so the supports allow this green part here to have something to go on top of. It goes on top of the orange. And now when the green part needs to be built, it just goes right on top of the orange, just like that. So there's some surface for the printer to go on. And if you change the orientation, you can actually get rid of these supports. So let's just do that just to show you. So this is a powerful software, and we can change the orientation by flipping this around. So if we take this part and put it on the bottom, now when we slice it or get a preview of it, there's no part of the object that is going to be printing over empty space. There's no part of this object that's printing over empty space. So now you can see there's no orange material in the middle of the part. So this is good. It doesn't have any supports. We're wasting a little bit less plastic, and this is looking all good. So I'm going to start this print, and now it's being sent to the printer. Does anybody have questions about how the 3D printer works, how the slicing works, or like what did we do with this part? So assuming that we already have the part that's in green, what does the printing mean? How does it work? Anybody have questions about that?
Any questions from the audience? See, I don't see any questions in the chat either. You're welcome to also put your questions in the chat, everyone. But no, I think we're good. Oh wait,
Okay, that sounds good.
Caleb, did you have a question?
No, I was just gonna say I really liked how he put it, the analysis of the writing an essay, and it's so like when he's processing all this, it's like I take it back on like how to write an essay, and it's like making sense.
Yeah.
Exactly. Yeah. So this is like this part of it is like printing out the paper, right? So this is just like a really complicated way to print out the paper. So now we're going to talk about how do you write the paper? How do you put the words on the paper? And so we're going to go backwards in time. The reason why I started with step 3 is because, as you can see, this is going to take, it said it was going to take about half an hour. So I just wanted to get this started. Now we're going to go backwards and get back to this point. So how do we get this mysterious green object, and how do I know it's going to work? That's where we're going. All right, sweet. So let's get out of the slicer. So now we're gonna go back to step 1. So how did I come up with this idea? I was out camping, that's how I came up with the idea. And now we're gonna see, okay, where did we come up with the idea to make that weird box thing? So I'm starting with a motor and a fan. And I need something that's going to stand up upright. So I'm going to go over to a drawing board here, and the general approach that we're going to take for the motor is we're going to make a box around it. So if my fingers were a box, we're going to take the box and just cover the motor like this. Okay. And then on the bottom, there's the shell around the motor. We'll just extend a little bit below the bottom of the motor, so that way it'll just stand upright just like a box. So it's basically like, think of like a Rubik's Cube, but it's hollow and the motor fits perfectly inside of it to conceal the motor and let it stand up upright. That's what we're gonna do. So let's make a little picture of this, because this is one of the major purposes of drawing a picture, is that I can explain something to you and maybe it makes perfect sense in my head, but when I explain that to you, you very well just might have been like, what is he even talking about, right? So now I'm going to draw a picture and hopefully make it a little bit more clear. What am I trying to explain? What are we trying to make? Because it makes sense to me, but it might not make sense to you. So the approach is that we're just going to make a little box. So here's the box. Okay, so there's a box, and inside of the box, there's going to be a motor. So in red, this is a motor with a shaft coming out of it. So that shaft is this thing that's sticking out. And then on top of that is going to be the fan. So on top of this, there's going to be the fan. And so hopefully, if we design this correctly, we can get it so that the motor, the bottom of the motor is, that black part is what we're printing. That's the part we're designing. And that stays flat, and that makes the motor able to stand up. So once again, I'll direct your attention over to that second camera that I have down below of the workspace. And we're just designing a part that wraps around like my fingers would right here. And that part will just stand up on the table just like this, just like that. So that's the part that we're designing. Okay, so the next step is to draw some more views of this, get some dimensions. So make the drawing a little bit more clear. And so I'm going to take a side view of the thing I just drew. So I'm going to look at the motor this way and look at, we're going to make a shell around the motor, and I'm going to look at it from the right side. So if the right side of the drawing is here, this is the right side, I'm going to put the right side just down here, and we're going to take a 2D sketch of this. So let me draw the motor. So when I have the motor, I'm holding it this way. It's basically a square with a little shaft sticking out of it. And then it's a little hard to see, but there's a lip at the bottom right here. There's a little bit of a lip. And so you can kind of see that lip right there. So let me just draw that shape in red. We got the lip and the motor. And this is our motor. Okay, so that's a little side view, and we got the shaft sticking out just like that. Okay, now we need to build a shell around this motor. So the shell, I'll draw in black, is going to look something like this. That's what our shell is going to look like. And then the shell needs to have a hole in it right here so that the shaft of the motor can stick out. So in general terms, this is what we're designing. Hopefully it makes more sense what we're making now, what this shell is going to look like. And the next step that we're going to need to do is figure out how big all of this is. So I could tell you, oh yeah, the motor's, you know, about half the size of my pinky or whatever, right? Yay big. But what'll be really useful is if we can get dimensions of this that we can put into a CAD program, so that that way the printer knows how big should I print this part. So in order to come up with those dimensions, I'm going to use this tool, which is called Calipers. So this tool right here, it's basically like a ruler, but it's a little bit more precise, and it's a little bit, it's like the engineer's ruler, what we use in the real world now that we have technology. So when you extend out this calipers, you get a reading on it. So this reading says 2.4 millimeters, and that reading is telling me the difference between the distance between right here and right here, which is also happens to be the same as the distance between here and here. And it's also the same as this distance sticking out. So if I stick this out farther, the dial will say 5.19 millimeters. And that's the distance from here to here, which is the distance from here to here. That's the same as the distance to here. So this is the engineer's rulers. Honestly, if you end up making a lot of parts, this is the best investment ever. This is such a good investment. This is called calipers. You can get them on Amazon, get them anywhere. So useful. And so I'm going to show you how to use them. It takes a little bit getting used to, but not that bad. So looking at it from the right side, I want to figure out the length. So I'm going to figure out the length from here to here, to kind of like this length that my pinky's going on right now. So I'm just going to take the calipers and put the calipers from one end to the other end, just like this. Okay, and the dimension I get is 27.3 millimeters. So let's round that up to 27.5 millimeters. So that's from here to here is 27.5 0.5 millimeters. That's why calipers are so nice. There's no guessing. There's no guessing in between rulers. It just tells you, which is so nice. The next dimension we want to get, looking at the right view, is from the top to the bottom. So let's take a dimension, top to bottom, and that is 14.8 millimeters, which will round up to 15. So take this and call it 15 millimeters. Okay, so that's how calipers work. And these dimensions are going to help us so much when we're designing this in the future. Just like, if you're cutting something out of wood, you got to measure twice, cut once. This is your measuring part. So the next dimension we need to figure out is how long this lip is. And so I've already measured this with calipers from here to here is 8.5 millimeters. Okay, and then just like a box, we need a length, width, and a height. So if I gave you these dimensions already, you also want to know, kind of flip it around, how long is this length right here? And so this length right here with the calipers, if I take that measurement, is 19.9 millimeters. So we'll call that 20 millimeters. And on the picture, that dimension would be right here, 20 millimeters. Okay, and one more dimension we would need. I think there's two more actually. So now we need to think about this hole here, right at the front. So as you can see, it's kind of sticking out a little bit, sticking out of the outside of the front of the motor a bit. And the amount that's sticking, I'm going to use this part of the calipers to bring this part right down and get that dimension. And that dimension is 2.5 millimeters. So the dimension of this height here, 2.5. Then the last dimension is the diameter of this hole. So the diameter of this hole, I'm going to take the calipers, measure around the hole. So around the hole right there. And that's giving me 6 millimeters. Okay, so this is our part. We've got all the dimensions. And this is your idea phase. So we got an idea, we sketched it on a paper, and I guess we've started the design phase. We've refined this sketch, we've gotten a side view of it and put our dimensions on the page. So does that make sense to everyone, what we did? Took the part, I got the idea in my head, I sketched it on a paper, dimensions.
Makes sense to
Yeah?
me.
Okay, that's good. This is good. See, this isn't so bad, right?
Yeah.
Now we just gotta take this and transcribe it onto a computer. And so in order to do that, you use a computer-aided design program. So in other words, a CAD program. And the CAD program that I'm gonna be using today is called Solidworks. It's a thing that's used in the industry quite a lot. There's a few others which I'll mention. I can mention at the end if people are interested. Solidworks is industry level. There are entry level and beginner level ones that I've used in the past, and then it kind of ramps up. SolidWorks is capable of a lot of stuff. So let's take a look at SolidWorks.
Raj, could you list some basic ones?
Yes, yeah. So the basic CAD program is called Tinkercad. That's the one that I've used, and you can do basic stuff there. There's also what else is there? There's Autocad is another one that could be good. It's in between Tinkercad and SolidWorks. Another one that's similar to SolidWorks but a little bit less expensive for hobbyists and other makers is called Fusion 360. And so that's also used in the industry, but it's a little bit cheaper than SolidWorks. So yeah, we can always talk. If you ever want these resources or the names of these things that I'd recommend, let me know. There's the good thing about CAD programs, there's lots of tutorials online, and I can always hook you up with resources on, how to CAD, give you some tutorials and give you some suggestions for software to use.
Appreciate that.
Of course. All right, SolidWorks. This is for me, this is the most fun part. So this is like, now we're typing the essay on the computer, typing it into Microsoft Word. This is what we're doing now. This is using SolidWorks. Okay, so the lay of the land here. So SolidWorks, you have 3 planes. We're doing stuff in 3 dimensions. So you got like your kind of like X, Y, and Z plane, or your front plane, your top plane, and your right plane. So this is the lay of the land here at SolidWorks. And how SolidWorks works is that you sketch things in 2 dimensions, and then you extend it out into a 3rd dimension. So you start with a sketch, and then you extrude outwards. So let me just show you how to make a little cube. So we're going to start with a sketch on the front plane. Just make a square. So the sketch is in 2 dimensions, just like that. And then we can take this and extrude it, bring it out to the 3rd dimension, and make it 2 inches. And now we have a cube. So we start with a rectangle, extended that for some distance into the 3rd dimension. Now we have a cube. And so we could do this again if we want to start over and maybe we want a cylinder. So going to delete this sketch and make another sketch. So if we want a cylinder, we would be taking a circle and extending it into the 3rd dimension. So if I've got a circle and we extend it into the 3rd dimension, now we have a cylinder. So this is the basic of how SolidWorks operates. Start with the sketch, extrude it out. All right, so now let's start making our part. So we're gonna do a sketch on the front plane. Let me switch into millimeters. Right now we're in IPS, which is inches units. We're gonna switch to millimeters because that's what I was measuring in. Okay, and let's see, so we got a sketch on this plane. All right, so this thing is basically a cube, a hollow cube. So the shape that we'll start sketching is going to be a rectangle or a square. So let's start with that. Put a rectangle on, and we want to give some dimensions to this. So we can start with the dimensions we used here. So we have a length of 27.5 inches and a height of 15 inches. So let's put those in for how long this should be. That's the great part about SolidWorks, is that I can just tell SolidWorks, okay, I want this to be 27.5 inches. And I want this length to be 15 inches. And then there we go. Now sorry, this isn't inches, this is millimeters. 27.5 millimeters and 15 millimeters are the dimensions of this square. And then I'm going to bring this out into the 3rd dimension. And how long do I want this to be? Well, how long I want it to be is 20 millimeters right there. So I'm going to take this dimension and make it 20 millimeters. There we go. We got a cube. That's the proper size. So we don't just want a cube. We want a cube that we can insert a motor into. So this has to be a hollow cube. So in order to make this a hollow cube, we're going to make another sketch and then make a rectangular cut into the cube that we created. So we want to cut from this side right here. We're going to cut and take out the majority of the material to make this into a shell that we can put a motor into. So go into SolidWorks, and we're going to cut from this left side here, where the dimensions are, we can measure it. It's 15 millimeters by 20 millimeters. This is the place where we want to be cutting. And then we can make a sketch, and I won't dimension this yet, but I just want to show you this is how we're going to do it. We're going to extrude cut and make a cut inside of this. So it's a 2D sketch that's cutting a portion out of the cube. And now to get some dimensions to make this the proper size is we want the top to be, let's see, so we're looking at it from the left side. We would want the top to be 20 millimeters. Okay, so now we're going to get to something interesting here. So let's take a pause. So when I got my fingers wrapped around the motor, right? We measured from this side of the motor to this side of the motor, right? And we said that was, what did we say? I think this was 20 millimeters. That's the dimension, that's 20 millimeters, right? And so we said, okay, that's 20 millimeters. And so as you can see, I have this cube, which we've dimensioned to be at the top here is 20 millimeters, right? That's what we've got. But the problem is that 20 millimeters is the distance from this side to this side, and that's the inside of my fingers. But my fingers have some thickness to it. So the top needs to be from the outside of my finger to the outside of my finger, or from the outside to the outside. So there's some thickness of the walls. The inner cut actually needs to be 20 millimeters, and the outer cut needs to be a little bit more because we're making a shell that has some thickness, right? So this would be like if you're cutting something out of wood, the wood has some thickness that you need to account for when you're cutting it. So to account for this, let's add 5 millimeters to all the dimensions. And you'll see why in a second. So if you're lost here, that's okay. This is a little confusing part. Just bear with me, and I hope it makes sense in a second. So we're adding 5 millimeters to all of these. We're making this 25. Okay. So now, when I'm doing this cut, now I want the dimensions to be exactly what we drew. So I want this to be exactly 20 millimeters, and I want this to be 15 millimeters. So now, when I make this cut, the inside of the motor is getting inserted. That is 20 millimeters by 15 millimeters. That's the dimensions that we decided on that we wanted to use. Okay, so if I exit the sketch here, now this is 20 millimeters and this is 15 millimeters, and that is where the motor is going to be inserted. So now this will be a perfect fit, like a glove onto the motor. Okay, so we have to properly center this. So the great part about Solidworks is that you can really easily dimension the size of the hole and also where the hole goes. So if I added 5 millimeters to the top, then on either side, there should be a 2.5 millimeter gap to center this. So now this is centered. So 5 divided by 2 is 2.5. This is where math class is going to come in, right? So now this rectangle cut is perfectly centered. Okay, and so we can exit the sketch. We have a perfectly centered cut. The only thing we need to think about is now how far do we want it to cut? And so if we look back at our picture, we're asking how far in should we cut? And we want it to be 2.5 millimeters away from the edge. So we can cut, with Solidworks, we can cut offset from the surface. So we can offset it from this surface. That would be this surface, and we can offset it by 2.5 millimeters. So now there's another 2.5 millimeter wall right at the front. So just to reconvene, the inside dimensions of this should be exactly what we have on the paper, 15 millimeters by 20 millimeters. And then the inside here, the length is, okay, so that's not quite right. That's 30 millimeters but we wanted it to be 27.5. And so the reason of this, those of you who like math, you might understand this. So the reason for this is that we ended up cutting on these two here, right? We have the outside is 25 millimeters and the inside is 20 millimeters, right? So there's 2.5 millimeter gaps. So that's why it's 5 millimeters more. But over here, we only have 2.5 millimeters between here on the inside and here on the outside. So there's only one 2.5 millimeter gap. So we actually have to change this sketch. We can change this sketch so that instead of 32.5, we make this 30. And now the inside would be 27.5 millimeters, which is exactly what we have on the paper. So now we're good. And so SolidWorks, the actual getting something on the screen is not that hard. The really hard part, and the reason why I spent all that time measuring stuff, is so that we can make sure that, you measure twice, cut once, right? You gotta make sure that all these dimensions are correct, and otherwise you're gonna get a part that looks good, but it's not gonna fit. Wouldn't fit nicely around this motor. Okay, so we have a shell. So the motor would insert into here. This is the top of the motor, and I'm holding it up like this. This is a shell that would go around the motor really nicely. The next thing that we need to do is get a little hole cut out right in here. So we can cut out a hole. So I'm going to start a sketch on the front here. And with this sketch, let's see, there we go. So we can put a little circle on here. We decided that we wanted the diameter of this to be, we put 6 millimeters on the drawing. So this is what we measured, 6 millimeters right here. And then we have to center this. So we can center this. It should be 10 millimeters from that side because this is a 20 millimeter long thing at the bottom. It's 20 millimeters. And then this side is 25 millimeters. So it should be 12.5 millimeters from the, should be 12.5 from the top.
Or
Right.
Roger, just want to give you like an 8-minute warning. Maybe you might want
Okay.
a few minutes just for a Q&A as well.
That sounds good. We're almost done with this part, and then we should be good. Thanks, Jacoby. So then we're going to cut here. And so again, we got a 2D sketch, and we're cutting again. So the cut is going to go up to there, and now we have a box with a hole. So that's not quite centered. Hold up. Yeah, because this is 25 millimeters, so this should be 12.5 right there. Okay, so now that's a centered hole. And yeah, this is our part. We have that little lip that we had, and so we have to do one more cut. This 8.5 millimeter lip at the back here, and so I'll just do this last cut, and then we should be good. So let's see. So we're going to make a little sketch right here. Should be sketching, and let's see, we're going to make a box. We want this box to be 8.5 millimeters tall, and then we cut. We're going to cut up to this surface, and now we have something with a hole in it. Let's just get that little thing right there, this little extra bit. So we want a dimension from here to here. The distance should be 0. And there we go. Now we got a nice cut. So this is our part. This is exactly what we were seeking out to build. And all this was some 2D sketches and bringing it out into the 3rd dimension with cuts. We got a circular cut in there. We got some square cuts, and that's all this part is. That's exactly what we drew. And this is the fly swatter. So this is the part that then I saved to my computer, and this is the exact part that I have right here. So in the 3D printer where we all started, this is the part right here. It's got this hole, it's got a little cutout, and it has a shell. This is exactly the part that I just designed. And so using the drawing, all that we did is we transferred that to the Cad program. So this is it. We just recreated it from a blank screen in the Cad program, and then send it to the printer program, and we printed it. And now at this point, we should be ready to go. So the print is complete, and that print is done. So I will be right back. I'm gonna go grab this part. We can assemble it. And at this point, our work is pretty much done. So this is the exciting part. Be right back.
Awesome. Thank you so much, Raj. So while he's doing to grab that part, if anybody wants to grab a drink, get up, stretch. We're almost done with the workshop. But oh, look, he already grabbed it. It's pretty fast. Cool.
All right, guys, this is it. So this is the piece that we've been working on the whole time. We got this little thing to take off. So just gonna take off this piece right there. All right, this is it. So this is the box with a hole and that little lip. And so now I'm going to take this. I'll stop sharing. Here we go. So I'm just going to take this and insert the motor right in here. So then when we insert the motor, now we have this thing concealed, and we can put the fan on top. And now if I draw your attention to that other camera, you can see that this just fits really nicely right on the table right there. So now it stands up. This was the whole goal. So now we can.
I got to pull up the other camera because I think I pinned the wrong video here.
Oh, okay. Yeah. Go for it. You see that camera?
I'm not seeing it.
Oh, okay. Hold up. Let me turn on my phone again.
It just shows your picture on it.
Okay, got it. There we go. Does it show now?
So let me go ahead and pin that one. So.
All right, this is it. And now it's standing. So this is our whole thing, and I can spin this up. So I've got a little battery right here. Let me connect it, and then we can see this fan actually spin to keep away the flies. So we got this. Yeah, this now it's spinning. There we go. So this is our whole. This is the product, right? This is rapid prototyping right here. Within the last 45 minutes, right? We went from nothing to something that actually stands with the motor and the fan, and now we don't have any more flies on our feet. So there we go.
That is real. I'm impressed. I'm very impressed.
Thank you. Yeah.
Good job.
I mean, so it wasn't. This shouldn't be impossible, right? Like it's not. It might seem hard, right? But it really, it's not that bad, you know. Like getting familiar with these tools, it's just, 2D sketches, thinking about it the right way, using these things to measure everything, and then you can get a real part. So I'm happy to answer any of your questions. Yeah.
Yeah, I'm definitely going to order some calipers for the rec. I don't know that we even have any. I know we've got some 3D printers, but I don't think we even have any calipers. So also, if there's anything else that we need to order, just let me know, Raj. And we'll
I think this is all you use, right? It's really it, Got some software, got the printers, which the rec has some access to, and
different colors. And all different colored of the material, so you can make a rainbow if you wanted. So
exactly, yeah.
Cool. So we have a couple more minutes for questions. Does anybody have any questions last minute that you'd like to ask Raj? All right, Angela, would you mind showing the video of Raj's startup? I'd like everybody to see that.
Absolutely. Here, let me share my screen really quick.
Cool.
Here we go. And
hi, I'm Raj Pabari, CEO of Off-Grid Technologies. your phone ran out of power right now? You might dash to the nearest power outlet. But what if you were out camping, hiking, or fishing? What if you were a soldier in a war zone and your equipment ran out of battery? Having access to power could be the difference between life and death. To solve this problem, the off-grid charger, or OG charger for short, uses the energy of a river to charge your devices. With the integrated battery pack, you'll always have power when you need it. The shell has been fluid optimized, so you can tie off a rope to the back and let the generator spin away worry-free. Plus, the OG charger is portable. It is roughly the same size as a water bottle and weighs only 1.5 pounds. The OG charger keeps your life running with reliable charging anytime, anywhere. Visit our website at offgridcharger.com for early access.
Very cool. So that's Raj's startup, all made with 3D printer, right?
Yeah, all of that. So like that product was made literally using this exact same approach. Like, you know, idea, design, create. That's exactly the approach. I used Solidworks, used 3D printers, made sketches that were pretty, you know, got the job done just like that. Exactly how you make a complicated project like that.
Yeah, that's awesome. Yep, it works. I mean, that whole rapid prototyping, it works. So that was very cool. Thank you so much. Again, the recording of this will be available. Raj, if we want to connect with you, LinkedIn's the best, right?
Yeah, LinkedIn's the best way. I put my link in the chat if anybody wants to connect. I'd be happy to.
Perfect. And Jacoby, any other announcements that we need to make sure to make before we end tonight?
Yes, I just want to say, like Tanya was just saying, you could watch this workshop and our past workshops on YouTube. I just dropped that in the link. I just dropped that in the chat. I also dropped the link to give Raj feedback on this workshop today. And then also I dropped the link to register for future workshops we have coming up. And that's it.
All right. Well, with that, thank you very much. We will see you all at the next workshop. Thank you so much, Raj, and everybody have a wonderful evening. And
Thanks,
good
Raj.
job. All right. Thanks so much. Take
Thank
care.
you.
Bye.